Hello, and in this video we're going to investigate some polynomial functions in section 4.1. Now this is one of your worksheets found in your document folder, so if you want to try this out first before you watch the video, you can check your work and see if you know what these things are. If not, you can follow along and then go back and try it after a while and then come back and check your answers after that. So in this first example, we have f of x equals negative x cubed plus 4x plus 9. Now our degree is the degree of the term. This is our highest power, so our degree is 3 here. Let's say degree is 3. Now our leading term is this term here, so that's going to be negative x to the third. Our constant term would be the number at the end, which is, well, if it has no x, then our constant term is 9. All right, now we're going to look at the end behavior. Now the end behavior is going to be based upon the negative x cubed, as we saw in the last video. This function is going to look something like this. It's going to have something in the middle here, but it's going to look like this, like it's a negative x cubed graph. So that means as we go to negative infinity, that goes this way, we're going to go to positive infinity here. And as we go to positive infinity, that means we go right, we're going to go down to negative infinity. All right, we're going to look at these things by looking at the graph. We're going to take a look at our graphing calculator and answer the rest of the questions on this. Now, I've plugged in all three of these here. This is the first one, negative x cubed plus 4x plus 9. The other two are going to be examples 2 and 3. I just wanted to save a little time by not typing them in or typing them in advance. I didn't highlight these ones, so that means they won't show up on the graph right away. So we're going to do zoom 6. That means we'll start with the standard viewing rectangle and see if we see everything. Looks like we need to go a little higher. We're missing a little bit of the graph. This comes down, goes back up, and then goes back down. It does look like this with a little jog in the middle. So we need to make our window a little bit bigger on the y-axis. So maybe if we go to 20 here, we see the graph, see the whole graph. See that? We can get a good grip on the graph. So that means my x minimum was negative 10, my x maximum was 10, my x minimum was negative 10, and my x maximum or y maximum was 20. We changed that y max. We got a graph that looked like this. Okay, so our number of x-intercepts was 1, right down here. Our number of turning points was 1, 2. There were 2 turning points. It turned right here, went from down to up, and then from up to down. So there's 2 turning points. And our symmetry, we have 2 types. We don't have any, it's not origin symmetry because it doesn't go through the origin. So this one has no symmetry, none, neither. It's not odd or even. Even means we can fold along the y-axis. Well, we can't fold along the y-axis. Odd means we can rotate 180 degrees around the origin, which we can't do that either. So this one is neither. Okay, and that's our first example completed using the calculator to help us out with some intercepts and turning points and end behavior. We can also use our end behavior here. Okay, so let's take a look at the second example. All right, so our second example is g of x equals x to the fifth minus 9x to the third plus 9x. Now, in this case, our degree is 5 because that's our highest power. Our lead term is x to the fifth. Our constant term, we don't have one. There's no number here, so our constant term is 0. Now this is x to the fifth, so it's odd and it's positive, so that means it's going to look like this with something in the middle here. Like we had on the other one, we had a little loop in the middle, but we should see the ends being the same. It's positive, so it's going to be going up. So that means as it goes to negative infinity, we're going this way, so that's going to be negative infinity here. As we go positive infinity, we're going to go up. So that's positive infinity. We're going to take a look at this now and see if we have how many intercepts, how many turning points we have. All right, so we're going to go back to our function, and we're going to turn this one off. So we can move over here, hit enter. We're going to turn on our second one, so I don't have to type it in. There it is. So we'll push zoom 6 again, start off with a standard window, see if we see it all. All right, looks like we need a little more y values. We don't need any more x's, but we need a little more y on each end. So let's change the window to y values of -20 and +20. We don't see enough of the loop here. We're going to go by 2's. And we're going to graph. Okay, we still don't see enough. I don't see enough of the loop. I don't see the top of this loop. So let's make it just 5 more, probably is all we need for these. 25 and 25. We can go to 30 also, but I think 25 is enough. Yes, I can see it now. All right, so it goes up, comes back down, goes up, comes back down, goes up. So that means our max and min for the y was 25 on our graph. So our x's were the same, -10 to +10. And this one was -25 to +25. Now we look at their graph again. It looks like we go up to a point, then we come back down, go through the origin. Okay, so it looks like we go up, we come back down, we go through the origin, and we do this, and we go back up. So let's try that again. So we went up, comes back down, goes through, goes back up, goes back down, then it goes back up. So it looks kind of like that. All right, now next number of x-intercepts. We count that 1, 2, 3, 4, 5. We have 5 x-intercepts. Let's double check on our graph calculator. Got 1, 2, 3, 4, 5. Number of turning points. 1 to turning here, 2, 3, 4. 4 turning points. And symmetry. So can we fold along the y-axis? So it's not even. Can we rotate here? So we can rotate here. We can rotate 180 degrees, so this is odd. Another way to see that, another way to see odd and even is to look at the powers. This power is 5, 3, and then 1 here. So all the powers are odd, so it's going to be odd. If we look at this previous example, we have 3, 1, and 0. This has an x to the 0 in it. So this one is even powered, whereas the 2 is odd. So it's going to be neither because it has an even and 2 odds. So if we have all evens or all odds, we should be able to get some kind of symmetry.